Okay, let me get the link real quick.
So yeah, I was wondering, like, maybe when we post up the link, we could just mention that Herdy wasn't actually here, but she did, kind of contribute and provide like what she got for her answers, so we could cross-check them and things like that.
Okay, I'll do
I
that
don't
real
know if
quick.
that'll get her anything, but I mean, she's trying at least. So, and her grandma was sick or something like that. So,
Yeah. Okay, I learn. Let's open it up. Yeah, I'll be happy if I escape this class with a B. I got an 85 in this class too.
dude, that's what I have.
I did the survey. She said she was gonna do what, 3 percentage points on your final grade if you
I
did the
think so, but
survey.
it won't show up until after the semester because she can't input it until afterwards.
Uh-huh.
So that's pretty solid right there, though. I mean, if you use, well, where is it? So at least for me, if I go in, I always use the what if calculator, but
I wish they had that on 3.0.
I know, dude. I have to like go and manually calculate that every time. I mean, if I
Mm-hmm.
get even a pretty low score of like a 60, I'll still pass with an 81. If I get a 50, I'll have an 80% exactly, and the 3%, and then we still have the final project assignments and stuff.
Mm-hmm.
I'll have to
It's
email Herdy
Hardy's
back.
turn this weekend, right?
I think so, yeah. So I need to email her and say, hey, you're doing the make inferences, right?
Yeah.
I'll email
Okay.
her after this, probably.
Okay, let's start the group meeting. Okay, I met with my group.
Oh, okay. Let me start mine. Are you on track next semester, man?
No, but I am taking a calculus class.
Nice. Just chill, probably work, right?
Yeah,
Aren't you
working.
going to be married soon?
August, so
Oh, so right after the semester's over.
yeah.
Okay, this is lesson 24, right?
Yep.
All right, I met with my group.
Number
Okay.
of people, telephone number of a randomly selected business in town.
I thought it was at least the number of people randomly selected classrooms on campus, right?
Mm-hmm.
But the other ones aren't, even though they do contain numbers. Isn't that right?
Well, the common brands is qualitative for
Right.
sure. On the telephone one, I mean, I can look that one up. What did Herdy say on this one?
Birdie only said the A, the first one, the number of people, but I was thinking number or C, I guess, would also pass for quantitative.
Yeah,
But at the
let's
same
see.
time, I'm not sure though, because it's not like, there's 10 of this or 30 of that. It's just a number for the business. So maybe it's not.
Yeah, hold on. Let's see here. Okay. Quantitative. Okay, I'm looking for it.
Are you looking at the book?
Okay. You can talk lesson 2.
Yeah.
Provide numerical information. They represent things that are numeric in nature, things that are measured. For a quantitative variable, it makes sense to apply arithmetic operations to the data. The net worth of a company or the number of people it employs are both examples.
Yeah.
Categorical variables yield data that can only be considered as categories. Categorical variables are labels, and it does not make sense to do arithmetic with them. Gender, nationality, job title, telephone number. Nice. Sweet. All right,
That's
just the
not
first one then.
okay. Sweet. All right, number 3. I ended up putting C question mark though. I wasn't sure. Observational study because the students have no control over the price of the cereals. Let me see what
Um,
Herdy
I
said.
I was thinking A, but I mean I was kind of unsure myself.
Herdy put an observational study because the students have no control over the price of the individual cereal. So yeah, she put C also.
Okay, that makes sense.
Which one did you think it was?
I was thinking it was A.
Oh, because the students had control over the method.
Yeah, but I don't think that matters.
All right, let's see. Number 4, I put D, not possible without the full set of data,
I put A.
because it's the median, right? We don't have the rest of the 99 samples or whatever. So we don't know which one is going to be the middle exactly.
Oh, I thought you were just going for this. Okay, yeah. I guess it would.
Oh, yeah. Let's see what she put. She put, yeah, it's not possible without the full set.
Okay, yeah, I read it wrong. I was like, okay, that makes sense. Sample
Okay.
deviation. Okay, yeah.
Number 5, I didn't know how to do number 5.
I got 95% because it's 2 standard deviations away.
That's what I
Um,
thought too, but isn't that a lot of people that completing in under 50% or 15 minutes?
yeah, but it goes both ways. So it's like it covers 50 minutes and it covers 90 minutes.
Mm-hmm. Wouldn't that be
Because,
only 5% then that does that? Because the 90% or whatever is going to be completing it at the mean of 70. I mean, this was just my thinking. Let me see what she said as well.
what percentage of students will complete under 50? Oh, yeah, I would say, oh, freak.
Okay,
What?
you know what Herdy said? She said 2.5. So I think what she did there was 5% of the students are completing it in under 50 or over 90, right?
Yeah,
And then dividing that by 2 gives you just the under 50, I think, right?
yeah, that makes sense.
Okay, that makes sense a little bit more. Okay. Number 6, find the 35th percentile. I actually got that one. I got 146.8.
Okay, how'd you do this one? I was lost.
Now, this one took a while. I had to look it up in the book again, and then it made perfect sense. So you know how you have your z-score equation, z equals value minus the mean over standard deviation.
Yeah.
So this time you're looking for. So you already have your z because you're given a 35 percentile. So in the applet, you type in your 35% at the top, and
Okay.
it'll give you your z scores. And since we're looking for the 35th percentile, it's going to be on the left half, right? So only the left portion is going to be shaded, which means the z-score is negative 0.385. And from there, you simply plug in the z-score. You have your u thing, which is the mean. You also have the standard deviation given to us, and you're solving for the x. Does that make sense?
Yeah, I'm trying to get my type it in the applet and it's like not letting me. Okay, finally. Okay. 35%. I type it
Yeah.
in and I get a z-score. But how many regions do I shade?
So since you're looking for the 35th percent, it's going to be the left part, right?
Okay.
Because 50% would be the middle,
Okay, I got
over 50 would
negative
be the right side.
0.385 as the z-score.
Yep. And then you're just reworking that equation. So it's going to be your x equals z times your standard deviation plus your u, which is the 150.7.
Okay.
Does that make sense, kind of?
Yeah, and your x is what you're solving for.
Yeah, because we know the u, which is the population mean or whatever. We know the standard deviation of 10.2. We know the z-score now because they gave us the percent. And so you're just looking for the actual value.
Okay.
That one took me a minute. I was trying to use the 157 and subtract and do all this weird stuff.
Okay. Okay, let's see here. Let me just work this out real quick. Okay, negative z x minus basically x minus 150 .7.
Yeah. So it's going to be, you're going to have your equation's going to be x equals z times standard deviation plus u.
Oh, x equals. Sorry, go ahead.
Um, yeah, because you're solving for the x. So I mean, even if you plugged in the numbers into just the regular equation, z equals x minus u over standard deviation, you're still going to have to solve for the x, and so you'd multiply standard deviation over, add your u over. Does that make sense?
Oh yeah.
So I just moved the equation variables over before actually solving, and then I just plugged everything in.
You got 154.63, 627.
I got 146.8.
How do you get that? Because I
So I did
got.
negative 0.385, right?
Uh huh.
And then you multiply that by 10.2,
Okay.
and then you add 150.7.
Yeah, let's see here. 2 times. Okay, yeah, I forgot to put the negative. Makes sense.
Okay.
146
So does that make
point.
sense though?
Yeah, 773.
Yeah.
Oh,
And then it says round it to 1.
1.8 then.
Yeah. And that's what
Alright,
Hurdy got as well.
sweet. Okay, for
Okay.
7, skewed right.
Yeah, so the first one, she got that as well. That one was pretty easy. Number 8, I got 2.236 as my z-score.
Okay, I did not get that. Let me rework this again.
That one took me a little bit too. See, the one thing that I'm having trouble with now is like remembering which number in the paragraph is the U and which one's the X.
I
But
got
this
it.
one luckily gave it to you.
Yeah, I got a point
What was
5 as
that?
my point 0.5 as my z-score.
0.5. How'd you do that?
Because 8,550 minus 8,544 divided by 12, right?
Kinda. So I don't know if it matters or not, but I also included the sample size in that.
Okay, where do you put that? Put the n.
And I actually also used, oh yeah, so I did 8550 minus 8544 like you did.
Okay.
And then I did divided by 12, which is the standard deviation, divided by the square root of 50. Or no,
Oh
20.
yeah, because of okay, that
So
makes
I feel
sense.
like if you don't have a standard deviation, then, I mean, if you don't have a sample size, you just use standard deviation or whatever it is, right?
Uh,
But if you have a sample size, I think you have to include that also.
gotcha. All right, let me see here. That makes sense. I forgot that. 2.24.
Yes, but I got 2.236. It asks for 3 this one.
Okay, yeah, I got that then.
Sweet. And let's see. Hurdy got 2.236. Yep. Okay. Number 9. Simple random sample. What is the probability that it's greater than? So I got for this one 0.991.
Okay, let me do it real quick. Wait, what was your Z score for this one?
Negative 2.357.
Okay, I got this wrong. Okay, let me try this again.
My wife went to Walmart this morning like an hour ago, and she's not back.
Dang. She
She was
buying the
like, yeah,
whole.
I'll just go by myself real quick. I don't
She
know. She
bought.
just needed to get some medicine for her, and she needed to buy like some baby food. She's like, yeah, I'll just leave the baby here because it'll be faster. But she's been over an hour.
It'll be fast. Okay. I'm getting
It's
a
like,
different Z score.
all
I
right, let me
thought.
see how I did this one because I wrote some notes down, but to be honest, I don't really. Oh, okay. Wait, never mind. Okay, so you did 8.5. Wait a second. I might have done this wrong here. Hold on.
Oh,
Let's
wait.
see.
I think I was doing the wrong numbers.
Oh, you know what? Yeah, because they in number 9 they use 8540.
Yeah. So let me try this again. I was sly. They
Yeah.
dirty rat. Okay, my z-score is way big now. It's like 5.89.
What the? Okay, so you did 8540, right? Minus 8544, right?
Wait, I thought I was minusing it from the 85550. Oh, okay.
No,
I
so
see.
you're just checking to see if the mean is 8544, right?
Okay, 4 minus
Um
8540. Oh, 4 divided by
yeah, and number
12.
9 you're using that it's greater than 8540. So that's your value. So then you get
Okay,
-4, right? But then you need
697.
to divide that -4 from the rest of it.
Okay, I got 2.357 as my z-score.
Yes.
Okay, and 0.0092 is probability.
Point zero. I got 0.0091.
What was your z-score?
-2.357.
Oh, so was mine.
Maybe Tyler? He left. Let's see. I'm getting actually 0.0092 right now also. But yesterday I got different than that.
That's
Oh
weird.
yeah, okay. Here's why. Hey, thanks. Because it's checking to see that it's greater than 8540. So you got to shade the middle and the right.
Oh, 9.9908.
Yeah.
That's our probability.
Yep, and so 0.991.
Wait, what?
So you got to round it.
Oh, 0.991. Oh, okay, I got it.
You gonna have a donut?
Okay, sweet. I hate these problems.
Dude, I know, me too, man.
I think it's D, but
All right,
I'm not
let's
sure.
see. Number 10.
Could be C.
I put C. I put
Okay,
C. Let me see
okay.
what she put.
I was like, it's either C or D.
So Herdy put the probability of a type 1 error.
Oh, what the freak? Okay, let me
I
look
don't
this
think
up real
that's right, though. Yeah, I don't think that one's right.
Let me look for it. What was it? Statistical.
The level of significance of a hypothesis. No. Oh, you must have flipped it on. Yeah.
Level of significance. I know a guy who's majoring in this. I feel like I would die.
Are you serious? I
Yeah,
would too.
just looking at numbers all day. Like, forget that crap. Where is it? Let's see here.
Wait, where do you look for that stuff? How do you find it so fast?
I just search it in the top right. Okay.
Hmm.
Test statistic. That's not what we're looking for. Level of significance. Here it is. Level of significance is
I looked this one up yesterday too.
we
I
need
feel
a
like.
way to determine if there's enough evidence to reject the null hypothesis that does not depend on the data. We need a number that can be used if the p-value is small enough to reject the null hypothesis. The number is called the level of significance. Okay. Level of significance is a probability of getting a value of the test statistic that is extreme enough that the null hypothesis will be rejected.
So that is a top probability of a type 1 error, isn't it?
Let's see here. Be rejected. In other words, the less level of significance is the probability of committing a type 1 error.
Balls. I didn't want her to be right for once.
I know, she's always right.
Which is okay, so wait, what is the probability of rejecting H0, whether it's true or not? Is that the p-value then?
Yeah, I think so. Let's see here.
Okay. All right. So that's A then, right?
Mm-hmm. Which of the
Number
following
11.
explanations describe the correct way? Oh, freaking A. I hate these problems.
Dude, so do I. There's a couple of these ones too. I always get these ones wrong on the test.
I know, every time.
Because, I mean, like, I even go back and look it up in the book sometimes afterwards. And it's like, we interpret this by saying this. And I'm like, that's exactly.
I know.
So for that one, I put B.
You put B. I put... Yeah, I think I put B too.
But let me see what she put, though, because...
Let me look.
Okay, number 11, she put, we are 95% confident that the true mean height of adult females in the United States is somewhere in our confidence level. Which one is that?
B.
That is B?
She only
Sweet.
chose one?
Oh, she put 2. She also put approximately 95% of all 95% confidence intervals that could be computed from the population of adult females in the United States will contain the true mean.
Okay.
Is that like takeout?
No.
Oh my gosh.
Jocelyn just typed in there.
So I guess it's B and C.
Okay, so here's the interpretation of the book. The correct interpretation of a 95% confidence interval is to say, we are 95% confident that the true mean lies within the lower and upper bounds of the confidence interval. So that's the first one.
B.
And
I guess that's kind of what the second one's saying as well, though, because I mean, it's not saying 95% of 95%. It's saying within a 95% confidence interval, about 95%. I don't even know. Never mind.
it's trippy. I'll just remember that for the test.
Yeah. So B and C then.
Yeah.
Okay, number 12. I put A question mark. I hate these ones too, dude.
Yeah. I put A too.
Let's see what she put. Yes, the distribution of the sample means is normal because the data are normal. So yeah, that's
Nice.
the first one. Nice, we did it. 13, I got 2 p-values. I didn't know which one's right.
Okay, so I got lazy and I was like, I don't feel like computing a p-value, but let me.
And I didn't get a value, so mine are probably both wrong.
Okay, let me see here.
How do we do this?
VMware. What's the data called?
Oh, we have to open one. It's called rates of return.
Okay. Have you seen Batman versus Superman?
No, dude.
I heard it sucks.
I've heard like both ways.
Really?
I've heard a few people that said it was pretty awesome, but most of the people said that.
Only because it leads up to a good intro to the Justice League. But other than
Yeah.
that, it sucks.
Oh.
That's true. Sets up the Justice League pretty well, apparently.
Mhm.
Okay.
I really want to see Suicide Squad.
Dude, that's the one I'm most anticipating. Like, forget the Avengers or whatever. Or, no, actually, the Captain America one, Civil War, looks good.
Oh yeah, that one I'm really excited for.
But, like, of as a normal Avengers, I didn't really care for it that much because there's no really suspense in it.
Yeah.
I haven't
Dude,
even
I don't know why everybody was super stoked about Batman versus Superman. I didn't really like. I wasn't too excited about that one.
I wasn't either.
I was
I
like,
think-
all right, that's cool, I guess, but whatever.
Yeah, it was. I wasn't very stoked for it either because it's like.
It's like, what's the probability that Batman's actually gonna win? I'm just kidding. We can calculate that
Pretty much.
with a p-value of 0.05.
That's funny.
All right, let's see. I finally got this open. So the known population is 0.95. Wait, don't we just use the data to do this?
Yeah, we don't have to do any math. I just didn't feel like opening my VMware last night.
So how do you just do descriptive statistics, and what?
Yeah, I think so. Still getting there.
No, that didn't give me the right answer because it's not. There's no p-value. What kind of test is this?
Okay, give me your notes. There
So
we go.
the test is to determine if the investor's portfolio performed significantly worse than the performance of the member of this arbitration panel. So
What is it called again?
rates of return.
Rate of return. All right. If I get a B, if I get a C in Chem, I'll just be like, I'm not going any further.
You don't have to take any of the other chems, do you?
I have to take 106.
Oh yeah, I'm taking that next semester. Kind of worried a little bit.
Yeah, but I can't get a C before. Like, if I get a C in 106, I'll be kind of sad, but at least I don't have to continue. But if I have a C before I go to 106, that's kind of scary stuff.
Dude, that's why I'm taking this again, and I feel like I've learned it a lot better this time around. But I'm still doing like not the greatest.
Yeah. Okay. What
So hey,
is
I don't even know what kind of test this is here. Is it just a
one sample
one
T?
sample
It looks like.
test? All right, let's see here.
What's
If that's the case,
what's the mean though?
the mean,
Does it give us that? Let's see here.
the known population mean is 0.95.
Okay. So I'll just type that in. 0.95.
Wait, do you have to type that in?
I always do for the test value.
Oh wait, how do you do that?
It pops up.
Yeah, 95.
So I
Maybe
got
that's why I got it.
0.039.
So yeah, I see that, and then I also got my 0.257 from before. But Herdy was getting, she got 0.20.
Maybe you don't type it in. Let me try it again. Maybe I'm wrong.
So I don't know how that.
Let me type in
I don't know
0.
how she's
0. Hers is 0.257 with 0, but what did she put?
doing that.
What did she get?
0.20.
0.20. Okay.
Yeah, I don't know how she did that.
She divided by 2.
Unless it's like a
Oh, she might have divided by 2. Is it 1/12?
Oh, hold on. So they just want to know that they perform significantly worse, so it would just be to see if it was less, right?
Yeah. So it's 0.01. Yeah, so it's basically 0.0 because it rounds up 0.02.
So 0.039. So we did it right the first time, right?
Yeah, and you just divide by 2.
Oh my gosh. Okay. 0.20. That makes sense.
Okay.
Wait, she didn't round to 3 decimals though.
How did she not?
No, she only did 0.20. Wouldn't it be? I'm gonna double click on this real quick and see, but
Wait, she put 0.20 or 0.020?
she just put 0.20.
Yeah, that's not right.
I feel like she probably meant to put 0.020 though, because I have 0.038, right?
Uh-huh.
On that thing, divide that by 2, it's 0.019. So maybe that's actually the answer.
Yeah, hold on. Let me see on my thing. I just had it. Okay. So 0.039 divided by 2 is 0.0195. But because that's 4 decimals, you round it to 0.020.
Wait, how'd you get 0.0195?
Because my sig two-tailed is 0.039. Why is this yours is 0.038?
Yeah, because I double clicked on it to find the actual value.
What the?
So double click on your sig two-tailed and then exit out of the little pop-up that comes up
Oh
and
yeah,
then
but it's
go back.
yeah. So I have in the sig it's 0.0387770.
Yeah,
But let's see here.
divide that by 2. Then I get 0.0193.
Oh, freak. Which one would we use though? Does she want?
Uh, I think because I've always double clicked on it and used that value.
And it works.
Usually, I feel like it's been working
Okay.
because the 0.039 is already rounded. So if you use that, you're using something that's already rounded.
Okay.
I'm
Let
not
me.
sure. I'm going to put 0.019.
Okay, I'll do that too.
But I don't know. Hopefully that's right.
Yeah. Okay. Financial whatever. Studying married. I would say dependent sampling.
Dependent sampling.
Yeah, the fourth one. That's what I put. But
Oh, see, I put D
okay,
because
sweet.
if he picks a husband or a wife, he's gonna have to include the other one as well.
Mhm.
So let's see. What did she put? She put she put that same exact number or letter D.
Sweet. All right, let me open this file real
Okay.
quick.
Which one is it?
Direct
Oh,
flight.
direct flight costs. Don't close that one either because you're gonna need it again later.
Okay, sweet. Round your answer. What is the p-value? Okay.
Yeah, I'm gonna open up that file real fast here in a sec.
Oh, it's what is this? Independent sampling?
I think it was paired data, isn't it?
Is it paired?
I feel like it is, but I'm not sure. That's where my question was.
Let's see here. A seat's still on, flight did not see well. An airline may discount tickets or even cancel the flight. This is 90 days. Oh, it's the same flight, so yeah, it would be paired. I thought it was two different flights. Paired samples. Boom. Boom. Okay, so my probability p-value is 0.00.
0.00.
Just kidding. I don't know what that was. 0.096.
Let me see. Where did you find the 0.0? Oh yeah, because you go all the way down, right?
Yeah. I was like, I don't know what I'm looking at, but I.
Oh yeah, I got 0.096. Herdy got 0.0962.
Okay, sweet. 0.00. Is there a difference? It's greater than. So no. Just kidding. It's
I put C.
okay. Yeah. So I guess I was right.
Let's see what she put here. She said no because the p-value was greater than the level of significance.
Sweet. That's the one we got. And I did, for this one, I got yes, because they have been determined to be normal.
Dang, I put D question mark because I wasn't sure.
Because they create a QQ plot and they say it's roughly form a straight line.
Okay. So in that case, it would be B.
B, yeah. What did she say?
She said, yes, the distribution of mean differences is normal because the data have been determined to be normal.
Okay, sweet. That's what I got.
So that's what you put. Nice.
Most appropriate pair of hypotheses for such a test. I would say
What
C.
kind of test was this again?
I don't know what type of test, but they want to see if the differences are different. And so I put C.
Isn't this an independent sample team? C.
Yep.
I put A question mark.
No, you're looking for the difference.
Oh, we are?
Yeah, which of the following? Let's see here.
Yeah, you're right. She put C as well.
Okay.
So wait, why do you use that?
Because the way it's worded. Now, suppose the company of previous item wants to determine whether the estimates given by the two appraisers are different. So you're looking for the difference in the two. So you'd look for the UD instead of U1.
Gotcha. I was just thinking because there was two people giving estimates. The first one would be the same as the second one was the null, and then the alternative is that they were not equal. But that makes sense.
Sweet. All right. Another stupid question here.
Let's see here. I put B, but I did have a question mark on that one.
Dude, I'll probably put I'm like I didn't put B, but based on what our last question was, that makes sense. What did Herdy put?
She put B as well.
Okay, sweet. Okay. If P equals 4/5, what is the smallest N?
This one was confusing for me.
Yeah, no, I was like, what the freak?
I think I got it though, because I got the same answer Herdy did.
Okay, I don't think I even tried this one. I was like, what the heck? So let me see if I can find something that will tell me.
You work on that one real quick. Hey, Casey.
Yeah.
Are you tutoring tonight? What the? Tonight?
3:30 to 10.
At night? Oh. This chat's coming over.
Are you serious?
Yeah. I was gonna say we could play Rocket League if you want.
Yeah, I don't have. I had to cancel my tutoring because.
Yeah. It's a month-end schedule.
Yeah, but then this is a 6 hours that I was talking
But that's not bad though. At least you're not doing 12-hour shift.
Yeah.
Remember when we did that?
Yeah.
That was the worst.
about.
All right. Well, we'll just have to rank up without you.
Yeah, for sure. Let me know.
Oh.
Let me see.
Okay, let's see. Those action and
Were you able to get a value?
let's see here. What is the smallest value for?
So you know what? You want to know what I did?
Yeah, what is your formula?
So since you're looking for the smallest value, remember the requirements for that kind of test? It's
Oh, the 10 thing?
yeah, your sample size times your p is greater than or equal to 10, and then also your sample size times 1 minus p is greater than or equal to 10. So doing that, you get, let's see, so you're doing, what's the sample size, or so you're looking for n. So if you have greater than or equal to 10, you divide 10 by 4/5.
Is it 13? I got
No,
12.5, but I mean, that's.
you have to do both of them though. Remember, it has to satisfy both of those.
Oh, yeah. What was the 1 minus whatever?
Yeah, so 1 minus the 80%, 1 minus the 4 divided by 5, right?
Times what?
Times your sample size.
Okay, let's see here. Divided by 1 minus 0.8.
And so you get 0.2, and you're dividing 10 by 0.2, and you get a different number.
50. So, yeah, it would be 50.
Wait, why is it 50 though?
It's 50 because 50 would satisfy both requirements, but 13 would only satisfy one.
Oh, yeah. Okay, perfect. Yeah, because if
Yeah.
you try to plug in 12.5 into the other one,
It would not work.
yeah. So that's how I got it. And that's what she got as well.
Sweet. For this one, I got D, but I wasn't too sure on it.
You got D or C?
I got D.
All right, let's see. I put B, but I was unsure. Let's
I
see.
debated between B.
So Herdy put no, 40 times 0.233. So yeah, she put the same one, D, as you.
Oh, sweet.
How did you guys do that?
I just basically did what we did in the last problem, but we used 0.233 instead of the average. So we used his real average instead of what his fake average was.
So you used 0.233,
Yeah.
and then you just plugged it into the requirement test?
Yeah.
Oh, okay. See, I was trying to figure some other weird calculation out.
Mm-hmm.
All right, that makes sense.
Okay. Geneticist conducts survey. Let's see here. So I got C.
Dang, I put A, but honestly didn't have any idea. So let's see. You put C.
Yeah.
She put 51.2% of the gametes in the sample have the male chromosome.
Oh, D. Okay, that makes sense.
Wait, so why do you pick that though? Because I feel like all these answers are so similar.
Because let's see here. So the sample, a random sample, and he determines that the milk
Proportion which contain the chromosome.
is 46%, but then he calculates proportion as 0.512. So 0.512 out of the sample would give you a male chromosome.
Oh, out of the sample.
Yeah.
Gotcha. I didn't get that part. Because I was like, B and C, definitely not the right answers. But then A, I was like, maybe? But that's not out of the sample.
Yeah.
Okay. That makes sense.
45% over 65. Fewer out of 320. 750. Okay, did you know how to do this?
So I'm looking at Hurdy's answer, and my answer is a little bit different. But what I did was so you've got your two samples, right? So it's a two proportion one.
Okay, so your X over
So
your
for
M.
a sample of, or wait, no, it's not a double proportion one. Never mind. So you've got your sample of 750, and you want to know whether or not fewer than 320 of them suffer from the conditions. So that's your proportion, 320 over 750, right?
Mm-hmm.
And that gives you your P, I'm pretty sure. And that's your P hat, right? So 0.427.
Yep.
And then from there, what I did was plug that into the equation that we used a while back. It's the P hat minus P over square root of P times 1 minus P over N.
Okay.
But I'm not actually sure now because Hurdy got a different answer than what I got. Maybe I just need a calculation error.
Oh, I'm on the page that talks about this. Okay, so. Oh, so we gotta find the Z-score and then we plug it in. Okay.
Yeah.
Okay, so we got 45.
I always get confused. What is P and what's P hat?
I
P
don't know.
hat's the one we just calculated, right?
Yeah, I'm looking at, so P1, so are we going to do, oh no, I'm looking at the wrong thing here. Let me back up here. Oops. Okay, here it is. Okay, it's P hat plus Z times P hat 1 over.
Let me see though. I'm getting a different number than I got last time, so let me just double check my answer from before.
Is it not? Is it not two proportions since we have two percentages?
I don't think it is two proportions, is it?
Oh, okay, I get it
'Cause
now. I
The
just saw.
45% is your P. That's the population mean, right?
Yeah, I just saw the equation that I needed to find.
But yeah, I'm still getting a different answer than Hurdy though.
Let's see here. I'm doing it right now. Okay, 45 is 1 minus 45. What was the sample size?
The sample size is 750.
Okay.
And since it's less, that just means you'd highlight the left portion of the probability applet, right?
Yeah, I
I
think
would think.
so. Let me see here. 2. Yep. Okay, 1.28.
That's what you got.
Z-score. Okay, so
1.28.
yeah. And then fewer. Yeah, so left side.
What
I
the heck? How
got
did you get that?
0.1003.
Okay. Actually, you know what though? Wouldn't that mean you have to shade the middle section as well? Because the mean is the 45%, right?
Uh-huh.
And or actually no, yeah, so that means we'd only shade the left.
What
Because
is Hurdy's answer?
her answer is 0.099. And so if you only shade the left, you get 1 point or 0.01, whatever, like you got. And that's what I got. If you shade the left section and the middle section, I'm getting 0.89. I don't know.
That's really close to our answer, though.
Which one? The 0.102?
Yeah, her 0.099, I feel like is, I mean,
Yeah,
rounded.
what was your answer again?
Her answer is like 0.001 away from ours, so I think we're on the right track.
What's your answer?
0.100?
Oh, see, I got 0.103.
Oh, yeah, I got 0.1003.
Huh. No, I got just 0.1028 and then rounded it to 0.103. But I don't know. That's the right way to do it though, right?
Yeah. I don't know. I'm just going to go with 0.100. Hope for the best.
Yeah, I think that's what I'm gonna do. I hope she gives us like some leeway. I wonder if she does.
I know, that's like, it can be like 0.03 in either direction or something.
Yeah.
Okay, suppose, okay, I've calculated. Area to the right. Which of the following is the p-value of your hypothesis test? Let's see here. Is it 0.0911?
So that's what I thought too. Did you just plug in the value?
Yeah,
1.334.
but then you got to divide by
But then you got to think
2.
about it. But you got to remember this though, because it even tells you right here the area to the right is 0.091. But look at the hypothesis. It's p equals 0.62 or p does not equal. And so that means it's going to be two-tailed, right?
Correct.
So in that case, you would highlight both ends and it'll give you 0.182.
Oh, tricky. Yeah.
Yeah. Let's see.
Okay.
Hurdy put 0.182. Because yeah, originally I thought it was going to be B.
Okay. Makes sense.
Okay. 25.
I
How
got
many measurements?
D.
Wait, why'd you get that? Is it because it follows a normal distribution already?
Yeah. Did you get A?
I put A, yeah, but I wasn't sure because it says it's a known that the distribution is normal.
What did Hurdy put?
She put what you put.
Okay.
So is that just because it already says it's normal?
Yeah.
Man. All right. 26. What?
It was just funny. It was like, all right, okay.
Yeah, no, I mean, it makes sense though. But I
Yeah.
just feel like there's a few questions in the past tests that I've missed because it says like, oh yeah, the distribution's this or whatever, and then I always pick the wrong thing.
I know. It's so dumb.
All right. So for 26, I put D, the last one.
Let's see here. 41.
What did you make? What did you make, Alex? Alex, what'd you make?
What?
What did you talking about?
I'm not sure I make guacamole.
Oh, dude, that was amazing. We had tacos yesterday. So good.
56.
Oh, did you get the?
Okay, yeah. I get the last one too.
Sweet. All right. 27. For 27, I put B.
Okay, yeah.
Sweet. That's what Herdy put also. 28, I also put, or I put D this time, but I wasn't sure.
Let's see. His predicted loss. Oh,
Yeah, this one is
residual.
confusing.
Yeah, I was like, what the freak?
Yeah,
I'm not sure on this.
I was trying
one.
to research what that meant. So Herdy put his actual weight loss was 5.5 pounds higher than his predicted weight loss. So that would be B, and so that's not what I put.
Let me look real quick.
Because when I looked it up, and I think I read that a residual is the difference between your observed value and your estimated value. Which that makes sense, but then translating it to this didn't really make sense to me. Because when your observed and estimated value, the difference between those, I feel like wouldn't give you, I don't know, like 5.5 higher than your predicted, but who knows?
Dang it, my book isn't working, man.
Really?
Let's
Let me
try
see
this
if I can
again.
look it up.
Why you do this to me?
Okay, here we go.
Here we go.
Residuals. Here we are.
Okay. It's
So,
defined as the difference between the observed value.
and the estimated or the predicted value, right?
Yes, observed and would have been predicted. So, so if he says the residual is 5.5 pounds, the prediction was that. So I guess his actual weight loss was lower then, right?
I don't know, because if your observed minus the predicted is 5.5, that means that there's a difference.
Oh, so I would say B then.
Yeah, it's higher. If it was a negative value, that means it would be lower, right?
His actual weight loss was higher. It's weird. It's so weird. Okay. Find the difference between the observed value and the value that would have been predicted. Okay, yeah, I would say B. Is that what you got?
Yeah, that's what I ended up getting eventually.
And she got D?
She also got B. I was the one that got D, but
Oh,
B makes a lot more sense to me right now.
sweet.
Okay, 29.
I got C.
Let's see. I put B question mark, but yeah, you're right. That's what Hurdy put too, and I didn't quite know why.
I got it
The
because
thing that,
B1 is slope, and slope is rise over
right.
run. So it's like, as this goes up, this is lost.
Okay, that makes sense.
Okay.
Okay, 30.
I
So for
got
30, I got, let's see here. I got A, C, D, and E, but I don't know if that's right.
Oh, that's what I got. I remember that.
You did?
Yeah,
Are you sure?
I can look. A,
Because
C, D,
I got A,
E.
C, D, E, but Hurdy only got 3 answers.
It might not be C or D. It might not be D, but
There's a linear relationship? I thought that was one of them.
okay, so maybe it's not D then.
Let's look it up real quick here. Where do you find those at again?
Let's see here. I'm on the same page actually. So linear relationship, normal error term, constant variance, known constants, and observations are independent.
Okay, so linear relationship is D, so that's true.
Okay, normal error term.
Normal error term. The variance of the error term is constant for all values of x. So yeah, that's right also, because Hurdy also has that one down. And
Okay.
then
Observations, constant variance.
constant variance.
That's
That's not even on here.
the variance of error term is constant for all errors of x.
Oh. Yeah, so I guess that would work.
X's are known constants. Observations are independent.
So the ones that she put the variance of the error term is constant for all values of x, which we got. She also put there's a linear relationship between x and y, which we also got. And then she also put the residuals are normally distributed.
Did you put that too?
That's what she put. Those are the 3 that she put down.
That's the one we don't have.
But that's the thing. That's not even on the check for the requirements, is it?
There's the normal error term, and how to check is the QQ plot of the residuals. So basically, it is on there, but it doesn't say it like that.
But then wouldn't the observations are independent also be a requirement?
Observations are independent. Yeah. Does
That's
she
one
have
of
that
them.
one?
No, she only put 3.
What the heck? Okay.
If you're gonna jump in.
I hate these check all that apply because I always get these wrong.
So I think
Linear.
it's gonna be the 4.
Yeah.
But I don't know.
Okay.
I'm
Linear
hoping it's 4.
relationship, normal error term, which is the QQ plot of the residuals. There's a constant variance, which is no megaphone shape in the residuals, which is a residual plot. X's are known constants. And observations cannot be checked directly or independent. So I think X values are measured without error isn't one of them.
Okay. Wait, are you sure though? Because look at number 4 on the requirements assumptions.
Oh yeah, should be measured accurately and precisely. Dang it.
Because if you scroll up a little bit higher too, go to number 3 in the book on that page, or section 3. It gives you the 5 assumptions, like a little bit more how they're written on the problem. Do you see that?
Oh yeah. Linear relationship between x and y. Error term is normally distributed. I don't see that. The variance of the terms is constant. X's are fixed and measured without error. Observations are independent. I think it might be all of them.
Really?
Yeah. I mean, what is the error term E? Is that residuals?
I'm not sure. I was wondering about that actually. Let's see.
Oh yeah, it is, I think.
It says E is a normal random variable.
Okay, so maybe the residual. I mean, but it makes sense though because it says you have to check the residuals and see if they're normal.
Yeah. So she only has those 3. I put A, C, D, and E originally, but now I have no clue.
Yeah, I'm gonna leave out B just because I don't think all of them could be checked.
Oh, the residuals are normally distributed?
Hmm.
All right. We'll see what happens.
Direct flight cost.
Yeah, that's the one that we had open, right? Okay, so compute the sample correlation coefficient. I forgot how to do that.
So you do
Is that what you do?
let's see.
Is that the correlate bivariate thing?
Yeah.
Let's see. Okay, I got the answer.
Okay, I got 0.780.
Yep, that's what I got.
Wait, is this the one we multiply though, or is that something else?
I don't think we multiply it.
Okay, because there's one. Isn't that the covariance that we multiply? By
Maybe, I think. I honestly don't remember the like covariance, variance stuff very well. But for this one, I got 0.780. That's what Hurdy also got.
Okay. Sounds good then. Oh yeah, it is the covariance that you multiply.
What do you mean? What do you multiply by what to get that?
Okay, remember we had to find the standard deviation of it, and then we multiplied it by that number that we just got.
Oh yeah, and then you also added the slope or whatever too, right?
Yeah.
Yeah, I remember that.
Okay. Sweet.
Sweet. Okay. 32 then. Create a scatter plot using these 2 variables. Use the scatter plot and referring to the correlation coefficient above, select the answer that describes the data. Wait, what does it mean by using these 2 variables? Just the before and after prices stuff?
Yep.
Okay, so scatter plot.
Let's do x-axis 14 days, 90 days, y-axis.
All right.
Whoa.
That is all over the place. Well, no, it's pretty linear though, don't you think?
So, sort of, yeah.
It's linear, but then with a strong. I forgot what all those different associations mean. Hold on.
Yeah, positive association means it's positive slope.
Yeah, when you go up, it also goes to the, or when you go to the right, it goes up.
What did she put?
She put linear with a fairly strong positive association.
Okay, that makes sense.
What are the differences between all those mean?
So fairly strong negative would be it'd be going down to the right instead of up to the right.
Because it's negative?
So
Oh, so the negative associations would be tilted the opposite direction, right? Down right.
mhm.
Hmm.
Okay, no. Let me
All right.
dang it. I lost my graph. Let me see. Scatter. Define.
I guess that makes sense.
Okay. Let's do regression. Regression linear. Independent. 14 random statistics. Okay, I got my line here. So I got negative. So your constant is
Oh, did
your
you?
y-intercept, right?
Yeah.
I got y equals negative 17.07 plus 0.972x.
Wait, 17.09, do you mean?
Negative 17.087.
Oh, okay. Mine just says 0.09.
Really?
Yeah.
That's weird.
How did you get that?
Uh, Basically what I
I just
did,
made the line appear.
I did the, I hit the button that says analyze. I did regression, linear, hit over 90 days as dependent, 14 days as independent, and then got my stuff.
Gotcha. So if you make your scatter plot, you can actually just double click on your scatter plot.
Oh yeah, I was trying
And
to
then
do
at the
that.
very top,
I couldn't remember how to do it, so
yeah,
I
there's a
did it
block.
the long way.
No, that's fine. All right. So are we doing number 33 then?
So we just finished 33.
Oh, we did? Okay. So the B0 is the y-intercept, right?
Yeah, the negative 17.087.
Oh, wait, but that's... Wait, she's not getting these answers, though. She
Wait,
got
what?
something weird.
What did she get?
She got 115.64 and 0.627.
What? Okay, hold on.
Let's see here. What about if you do...
I'm gonna try something else here. Let's do. Was this our last meeting?
I think so, dude.
Yeah, that's so sick. Define. I'm gonna switch my variables up and see if it makes a difference.
Okay.
Okay.
trying to think what else she could have done here to get that. The thing is, what do you even plug in for X and stuff? We don't know, do we?
Yeah, that's the thing. Let's see here. Let me try regression, linear. How what I did made sense, but
Yeah, it does. Well, that's what I originally did too. I don't know. The question just doesn't make sense to me. It just says fill in the missing variables in the equation of the linear regression line
okay,
to
for
predict
my
price.
new one, I got 115.64 plus 0.627x.
Okay, that's what she got.
Okay, so she had the variables confused, but I don't. Let's see here. I don't think she had the variables right though, because I feel like the independent variable would be the one that's 90 days away,
14.
or yeah, 90 days away.
Wait, I thought that was the dependent variable.
Let's see here. So let me see. So 90 days
Because we
away
just
would be the independent variable, I would say.
Oh yeah.
Because
I thought we just did it the opposite way though, didn't we?
did we? Let's see here.
Because my 14 is on the x-axis and my 90 days is on the y.
Okay, so my independent is 90 days. Oh, okay. So I guess I did have it backwards. This makes sense now. What she has. Dang it. I wanted to prove her wrong.
So wait, how did you? Let me just make my graph again because I want to see. So the 14 days is independent
It's
or dependent,
dependent.
and the 90 days is independent.
Yeah, that makes sense because it's the 90 days is really its own thing, but the 14 days is going to depend on things, on like available seats and stuff.
Oh, right, because it's closer to the flight.
Correct.
Okay, that makes sense to me. I was like, wait a second. All right, and then when you use it that way, then you get the same numbers that she got.
Yep. She's right
We
again.
just did it backwards. Man, I don't know how she does that.
So good.
All right,
Okay, predict the
34.
price listed 14, costing 200, 90 days before a flight. Okay.
So that's where you plug in the equation, right?
Yeah. So let's see.
Plug in, what is it, 200?
Wait, what?
Don't we just plug in 200 to the equation?
Oh yeah, into X. Yeah.
I think so.
I got 241.04.
Yep, so 241.0 since we have to round to one decimal.
Nice.
All
Okay,
right, 35.
5% confidence interval. I got,
How do you do this again?
so I just saw it. So what you're gonna do is you're gonna find you're gonna do analyze, regression, linear, dependent 14, independent 90 days. You click on statistics, You want to click on confidence interval 95%. Continue.
Yeah.
And I got 80.332 to 150.948.
All right, let me see what I got here. Yep, 80.332 to 150.948. And what number is this again? 35? She got something way different, dude.
Nuh-uh.
Yeah. She got 0.518 and 0.725.
Oh crap! That's the thing underneath us.
Oh. Yeah, I think that's
Oh
right
yeah,
though.
because we always use
98.
what's at the bottom, right?
Yeah, you don't want to use the constant one.
Okay, that makes sense. 518. There's so many stupid mistakes by us.
I know, dude. That's a lot of the time what I miss. The other day on one of my quizzes, dude, for homework, I had all the right answers except I forgot the decimal place on a couple of them.
Oh, jeez.
All right. Number 36. Choose the correct null and alternative hypothesis for the analysis.
Okay, so it's equal to, right? Slope is 0. What's slope?
Slope is B1.
B1.
Yeah,
Okay.
I think it's D.
I was thinking B.
So it depends. I'm not sure if we use the lowercase or the uppercase one.
Because if
I know.
if it's changing, then the slope is gonna change, and so you're like, hey, it's not gonna change, so it equals 0. But then your alternative is like, oh yeah, your slope is changing. That's my kind of explanation for it. But I mean, I could be wrong. What did Herdy say on this one?
Right. No, and I get that. She put the null hypothesis, and then she used an uppercase B1 is equal to 0. So it's either B or D. I know that for sure. And then she put alternative B1 not equal to 0.
Okay,
And so I'm
what
wondering
is
if she
capital
meant
B?
capital B is what did it say it was here? So B0 and B1 are the y-intercept and the slope. We know that.
Mm-hmm.
The beta ones, where it's the capital, those ones are unknown constants representing the true values for the population. So I don't know what that means exactly, though.
That's crazy. Let's see here. I'm saying if there's anything that I can.
Because I'm looking at it right here in the book, I feel like didn't really explain these parts very well because they're almost the same thing. It just says that beta 0 and beta 1 are parameters. And it's like, all right, that's great, but what does that mean?
What does that mean? What does that mean? Freak.
But yeah, it
Okay.
says we'll use the Greek letter beta to denote
Yeah.
these
It
true
just
unknown.
it just gave us. I just looked on lesson 23, and the null
Yeah.
hypothesis is the capital B equals 0.
Or not
B.
equal to 0. Okay, I think that's it then.
Oh, that's dumb. At the bottom
All
of
right.
the page, it says, next to the null hypothesis and stuff, it says, we conduct a hypothesis test on bivariate data to know if there's a linear relationship between the two variables. To determine this, we test the slope, capital B1, on whether or not it equals 0. Like, dang it.
That doesn't make sense though, does it?
I know. Thought the slope was little b.
Yeah, I know, me too.
Whatever.
I don't know. We'll have to be really careful with those.
Test
All right, man.
statistic. I got 11.509.
Let me see what I got here. Wait, how'd you find? Oh yeah, 11.509.
Mm-hmm.
She got 11.509.
Nice. 0.000.
For the p-value, yeah, 0.000.
You fail to reject the null. There is
It would be there is insufficient evidence. No, it would be sufficient evidence to suggest that the slope does not equal 0, right?
yeah.
So A,
What did she put?
she put reject the null. There is sufficient evidence to suggest that the slope of the
Sweet.
true linear regression line does not equal 0. Yeah, so that's A.
Sweet. Okay, these suck.
39 to 40.
Yeah.
Okay, what is this? Oh my gosh, all the different tests.
The mean
Okay,
birth weight to mothers is 2,800. Cure program first study. Powers. I would say F.
Test of one proportion?
Yes.
Wouldn't this just be
But I was thinking maybe B.
I was thinking, yeah, B, one sample t-test.
What did she put?
Let's see. She put B.
Okay, sweet. I don't know what I was thinking.
How do we write this in there? Do we just put lowercase b in the box?
Yeah, I guess.
Yeah. Wait, that one's a one sample t-test just because it's just the mean birth weight, right?
The answer type is letter A, comma B, comma C. Da, da, da. Okay, yeah, one sample t-test for 40. Let's see here. I would say A, right? Because we know we know the standard deviation.
Well, yeah, we do know the standard deviation, and we know they just want to determine whether the pressure is high enough. And I think that's it. Just A, one sample Z test.
Okay,
And
what did she
Purdy
put?
also,
She put A too.
she put A. Yeah.
Okay.
Dude, these are so hard for me, though. On the test, I know I'm going to mess these up.
41. I'm saying one proportion. F.
Yes, I believe so. Yep, because it's just the one percentage and the one, and that's what Hurdy put.
And then
Okay,
this next one, I had paired samples. C.
That's
Or
what
no,
I
wait, maybe two proportions. Hold on.
tested two proportions. Let's see.
Maybe. Oh yeah, maybe two
Yeah, it's
proportions.
two proportions.
Okay.
That's G, right?
Yeah, business marketing firm, radio advertising, hope to see sales. Oh, regression. I.
Linear relationship. Yeah, it's I. All
Okay.
right. Is
Here
that
we
all of them
go.
finally? That was long, dude.
Let's do this thing.
All right.
Okay. So far, so good. Oh crap. 25
25. Oh,
and
yeah,
30
dude.
and 30
30 was that one that we were wondering. It doesn't tell you the answers, though.
and 38.
38? Wait, what the? How did we miss 35?
Dude, I was probably insufficient evidence.
Huh.
Wait a second. We can retake this.
What? Why? We can
Yes.
retake that? Has that always been an option?
No. I don't know why it's an option now though. I'm copying and pasting in the Word document.
Are you really gonna do it again?
Dude, I'm gonna do it again. I gotta get my 100%.
What did you miss 35?
Did I miss 35? Let's see here. No.
Wait, why did I miss 35?
Did you get 0.725?
Yeah.
Oh crap! I put 0.735.
And you got it right?
Yeah.
What? Wait, where is that answer again? Oh, dang, it is 735. I'm doing this again.
Dang it! I try to copy it in Word and it's making my Word go crazy.
Did you already did you already end the broadcast and all that?
Oh yeah, I guess I should.
That's going to be a long broadcast.
That's true. Where's the? Here it is.